Good morning to one and all present here. I am Dr.J.Vinnarasi, Assistant Professor of Chemistry, the Standard 5X Rajaratnam College for Women, Sivagasi. Today we are going to see about a topic in General Chemistry 1, that is valence bond theory, VB theory. So it is a hard topic because in every competitive exams, for example TRB Polytechnic exam or TRB postgraduate teachers exam or CSIR GATE, NET, SET or any competitive exams, the questions asked from the topic valence bond theory. Today we are going to see the topics introduction, postulates, hybridization and what are the limitations in the valence bond theory. So the valence bond theory was introduced by Hitler and London in the year of 1927 and it was further developed by Linus Pauling for the coordination in valence bond theory and others. The covalent bond is formed between the two atoms by the overlapping of half-filled valence atomic orbitals of each atoms containing one unpaired electrons, because the VP theory is only for covalent bonds. So the covalent bond is directional in nature. So what are the postulates? Next we are going to see about the postulates. A covalent bond is formed by a overlapping of orbitals. The orbitals containing a half-filled electrons which are containing atoms. Second one is atomic orbitals undergoing overlap must be sufficiently close to each other with the proper orientation, where either is a half spin or the minus half spin. Third one is only valence electrons of the atoms overlap with each other. The inner orbitals, we can't bother about the inner orbitals present, the inner electron present in the orbitals, we can't bother about that. We have only see about the valence orbitals of the atom overlap with each other to form a bond by using a sharing of electrons. The fourth one is a pair of electrons with opposite spin. That's why the proper orientation of electrons present in the overlapping of orbitals. Next one, the strength of the bond formed depends upon the extent of overlapping, because the greater the overlapping, the atomic orbitals are stronger. They form a stronger covalent bond. Next one, the energy of the resulting molecule is less than compared to the individual atoms in the separation. The last one is the atom which unite to form a molecule completely retain their identities in the resulting molecules. So these are the postulates we see about the bonding in molecules. Next, what are the types of covalent bond presenting in the atom? The first one is a pi bond. What is pi bond? The overlap between the half-filled p orbitals on the carbon atom and the oxygen atom. For example, when the p orbitals overlap this way, for example side by side overlapping, the resulting bond is called pi bond. And the electron density is in and above the internuclear axis. When the orbital overlapping, end to end overlapping means the bond is called sigma bond. So first one is a sidewise overlapping, second one is a end to end overlapping. So these are the two bonds formed in covalent bonding. Next one is a hybridization. What is meant by hybridization? A hybridization is nothing but mixing of atomic orbitals. How we determine the hybridization? First determine the number and the type of atomic orbitals used by the atom. So hybridization is nothing but a mixing of atomic orbitals by the two atoms. So how will you determine the hybridization for a molecule? So these are the steps we have to follow to identify the hybridization of the molecule. Then only we predict the geometry of the molecule. So determine the number and the type of atomic orbitals which is used by the atom, which includes all the electrons in the valence shell. For example, boron. Boron, the atomic number of boron is 5. So what about the electronic configuration? 1s2, 2s2, 2p1. So with the 3 valence electron, the use of 1s and 2p orbitals. Then for example, we consider nitrogen. So nitrogen having the atomic number of 7, but the valence electron is 5. So what about the electronic configuration? 1s2, 2s2, 2p3. So with the 5 valence electron, we use as 1 s orbital and 3 p orbitals. So next, if there are pi bond presence determined by the Lewis structure, so it discount one partial filled p orbital for every pi bond. So what about the pi bond? So pi bond is a sidewise overlapping. So next one is a double bond. So the double bond is equivalent to 1 sigma bond and 1 pi bond. Next one is a triple bond. What about the formation of triple bond? They containing 1 sigma bond and 2 pi bonds. Pi bond is nothing but it is a sidewise overlapping. Sigma bond is a n to n overlapping. So we form a double bond means it contains 1 sigma bond as well as 1 pi bond. We construct a triple bond means it contains 1 sigma bond as well as 2 pi bonds. Next, what about the mixing? So we mix the orbitals to form hybridized orbitals. For example, we mix 1 s orbital and 1 p orbital. So the hybridized orbital is a sp hybridization. So what about the geometry? It is a linear in shape. So what about the angle? It is 180 degree. Second one is a 1 s orbital mixed with 2 p orbitals. We having sp2 hybridized orbital. So the geometry of the molecule is trigonal planar. sp2 hybridization and the geometry of the molecule is trigonal planar. What about the angle? The angle is nothing but 120 degree. Next one is a 1 s orbital is mixed with 3 p orbitals. We getting 4 hybridized orbitals is nothing but sp3 hybridization. The geometry of the molecule is tetrahedral. sp3 hybridization tetrahedral. The bond angle for the molecule is 109.5 degrees Celsius, 5 degree. Next, the mixing of orbitals, 1 s orbital, 3 p orbitals and 1 d orbitals. So there are 5 orbitals. So 5 hybridized orbitals are formed. The hybridization is sp3d hybridization. The bond angle between the molecule is atoms is 90 degree as well as 120 degree. The last one is a mixing of atomic orbitals of 1 s orbital, 3 p orbitals and 2 d orbitals. There are 6 hybridized orbitals. Is nothing but sp3d2 hybridization. So the geometry of the molecule is octahedral. So the atoms between the angles, the bond angle between the atom is 90 degree. So next we have to say about one example. So it's nothing but sp hybridization. So the molecule forms a linear structure or geometry. The bond angle between the atoms is 180 degree. How it forms? 1 s orbital is mixed with 1 p orbital. So it's a combination of 2 orbitals, sp orbitals. So the first one is a unhybridized atomic orbitals, 1 s orbital. It is a unidirectional. Then it is mixed with p orbitals. After the hybridization, we are getting a sp hybridized orbitals. So we see using an example. It's nothing but acetylene, a carbon containing 4 valence electrons. So it is an atomic number of carbon is 6. The electronic configuration of the molecule is 1s2, 2s2, 2p2. So the orbital containing 4 valence electron. So 2s2, 2p2. Then it mixed with the hydrogen atom, 2 hydrogen atoms. So hydrogen atom, what about the configuration of hydrogen atom? 1s2, 1s1. So another hydrogen, 1s1. So these are the atomic orbitals. After hybridization, we getting that sp hybridized orbital. So the geometry of the molecule is linear. So the image reflects the valence bond model of the acetylene molecules. So it containing a triple bond. C triple bond, CH triple bond CH. The molecule is acetylene molecule. The hybridization of the molecule is sp. What about the bond angle? It is a 180 degree. It is a linear molecule. So we know that the double bond containing 1 sigma bond and 1 pi bond. What about the triple bond? A triple bond containing 1 sigma bond and 2 pi bonds. So this image reflects that. What about the sigma bond as well as the pi bond? Second one example is a sp2 hybridization. So it is a mixing of 1 s orbital with 2 p orbitals. So we get a 3 hybridized orbital which is nothing but sp2 hybridization. So the geometry of the molecule is a trigonal planar, and the bond angle between the molecule is 120 degree. We simply take for example BF3 molecule, boron trifluoride. Boron is a electron deficient compound which bonding with fluorine we get a trigonal planar structure with the bond angle of 120 degrees, 120. For example, now we consider the sp2 hybridized molecule. Here ethylene molecule, C double bond C. So it forms a pi bond. So that it forms a double bond containing one sigma bond as well as one pi bond. So the image represents the bonding nature of ethylene molecule. Next one is a sp3 hybridization. So it is nothing but one s orbital is mixed with px, py, pz orbitals. So the left side image represents the unhybridized atomic orbitals. Then in mixing of atomic orbitals, we getting 4 hybridized orbitals. So that is called sp3 hybridization. So the geometry of the molecule is tetrahedral. The bond angle of the molecule is 109.5. So the image represents the tetrahedral molecule. So it's nothing but the example is a methane. A carbon's 4 valence electrons occupy the orbitals singly with parallel spin as per the Hund's rule. With the electronic configuration, the carbon has 4 half-filled orbitals and it can form 4 bonds with the 4 hydrogen atoms. So the geometry of the overlapping orbitals is tetrahedral with the bond angle of 109.5 degree between the orbitals. So that the resulting geometry of the molecule is tetrahedral. So it agrees the measure of the geometry of the methane molecule with respect to the VP theory. So next one is next we summarize all the concepts of valence bond theory. What is the summarizing? We can conclude what is VP theory. So VP theory is nothing but the valence electrons of the atoms in the molecule reside in quantum mechanical atomic orbitals. So the orbitals can be the standard s, p, d, f orbitals, or they may be a hybrid combination of these. Second one is a chemical bond results from the overlapping of 2 half-filled orbitals. The first one is a quantum mechanical atomic orbitals, or we just say that s, p, d, f orbitals. Second one is a bonding, it's purely covalent bonding. What about the bonding? The overlapping of 2 half-filled orbitals with spin pairing of 2 valence electrons, or the less commonly overlap of completely filled orbitals with an empty orbitals. First initially half-filled orbitals, or otherwise one is a completely filled orbitals, another one is a empty orbitals. So what about the third conclusion? The VP theory predicts the geometry of the molecules. The geometry of the overlap of atomic orbital determines the shape of the molecule. For example, a molecule, we have to know the geometry of the molecule. Using the VP theory, we can predict the geometry of the molecule. We can predict the geometry as well as the bond angle of the molecule. So what about the limitation? They have lot of facilities we have to find using VP theory, but there are certain drawbacks are there in VP theory. What are the drawbacks? VP theory fails to explain the tetravalency of the carbon. The second one, this theory does not address the issue of paramagnetic nature of the nature. The theory only explains the geometry of the molecule, but not about the magnetic property of the molecules. For example, the paramagnetic nature of oxygen molecule. But the VP theory explains the oxygen molecule containing a double bond. That's all. But it cannot explain about the magnetic nature, whether it is a paramagnetic or a diamagnetic. Then this theory fails to explain the formation of the molecule with odd electrons. For example, H2 plus or ionic molecules. We cannot predict the odd number of electrons which is present in the molecule. Next, it cannot explain about the bonding in electron deficient compound. with incomplete octet. For example, diborane, which has a banana structure. It is also electron deficient compound. So it is this structure containing 2 electron with 3 center with 2 electron. So VP theory cannot explain about the structure of the molecule because it is the electron is a deficient compound, as well as the compounds with having incomplete octet. So it cannot explain with the VB theory. The geometry of the molecule we cannot explain using VB theory. Then it explains only the covalent bonding. Initially we start with the theories, it explains the covalent bonding. It is a sharing of electrons, or otherwise the half-filled atomic orbitals mixed together to form a bond. But it cannot coordinate with the coordinate covalent bonding. It cannot. Then the last one is no discussion about the energies of the electron. What about the energies in the electron present in the molecule? We cannot explain. The VP theory explains it clearly explains the geometry of the molecule. Thank you for watching this video. For the next module, we have to see with the latest topic. Thank you.